In this video, we're going to look at the different types of data that we can see through statistical analysis. At the end of this video, our objectives are we're going to be able to define and learn to classify variables such as qualitative variables, quantitative variables, discrete variables, and continuous variables. And then we're also going to be able to define and learn to identify different types of levels of measure such as nominal, ordinal, interval, and ratio levels of measurements. So first, let's look at the different types of variables. There are two different types of variables that we can have. We have qualitative variables, which are variables that have distinct categories according to some type of characteristic or attribute. Some examples of those are going to be things like hair color, soft drink brands, and jersey numbers. The reason why these are qualitative is that there's certain qualities that give the variable here, that there are different types of hair colors such as brown hair, there's red hair, there's blonde hair, there could be strawberry blonde hair. There's different types of soft drink brands such as Coca-Cola, Pepsi, Dr. Pepper, all those, and even jersey numbers that we can give as a qualitative. Because even though the jersey numbers have a numerical value, we are just classifying them into categories such as all the different types of athletes that wear the number 23 as opposed to the different types of athletes that wear number 50 and so on. It's a categorized system out of this, and it's a characterization of everything. If the variable is not a qualitative, then it is quantitative in this case. So quantitative, you can look at the beginning of the word here. We have quantity, which means that we're able to give it some type of numerical value, or we're able to measure what is happening or count what is happening. So examples of quantitative variables, we have, say, the number of frogs, the distance a frog can jump, the temperature of the frog. And we'll come back to those particular examples a little bit later on in this presentation. Within the quantitative realm, quantitative variables can be one of two types. We can either have discrete variables, which are basically variables that can only be represented by counting numbers. There's no way to count it in between hard counting numbers, your whole numbers in this case. So some examples of a discrete variable are with the number of frogs in a jumping contest. You either have one frog, either have two frogs, three frogs, and so on. You can't have anything in between 1 and 2 because we would not be able to count 1.5 frogs. The number of basketball goals scored during a game. You either score 1 basket, 2 baskets, no baskets, 10 baskets, and so on. You can't score anything in between those numbers. And then we have the number of tomato plants in a garden. So again, you either have 1 plant, you have 2 plants, 3 plants, and so on. So these variables only can take on counting numbers such as 5, 6, 10, or even 1,000. Any type of counting number, but you could not take on some value that's a decimal. So 5.5, 10.6, and 99.9, and again, no decimal values. If it is not discrete, then we call it a continuous variable, which can be assumed by an infinite number of values between any two specific values. They're attained by measuring. So what are some continuous variable examples? We have the distance that a frog can jump. A frog can jump a foot, it can jump 2 foot, but it can also land at any distance between 1 and 2 feet. The temperature of a frog, that we could have an exact number such as like 98 degrees. We can go up to 99, but again, any degree measure in between there could also be measured for the temperature of a frog, and the same could be said with the weight of a frog. So the progression that you could look at this is that we have variables. Variables are either qualitative, there's a quality, some type of characteristic that can be measured, or there's a quantitative value that can be measured. And within the quantitative measures, it's either discrete, which is counting numbers, or it's continuous, which could be represented by any number, including decimals. Okay, so then we take our variables, and we can do different types of levels of measurements on it. So first one that we have is nominal level of measurements. These are classified data into mutually exclusive, which means that they cannot overlap in any other categories. It belongs to one category and one category only. Also, there's no order or ranking in this, that one category is not considered better than a second category. They're just mutually exclusive categories. If it's in this category, it goes to that category, and if it's in a second category, it goes to the second category, and so on. So here's some examples of nominal levels of measurements. Let's say we go out into the parking lot and we want to look at all the different colors of cars. Well, there might be red cars, there could be blue cars, green, silver cars, but A green car is not said to be better than a blue car, and a silver car is not better than a red car, and vice versa. They're just simply categories. They can't be ranked. There's no particular order that we can put these colors, but they also, again, do not overlap. There's nothing that can have in common. Another way that we could say a nominal level of measurement is that we can classify the residents according to zip codes. Again, zip codes are represented by numbers, but each area has their own zip code. But again, there's no ranking in the system. One zip code is not better than the other in that case, so it's just simply a category. Another level of measurement that we have is the ordinal level of measurement. Here we classify data into categories that can be ranked. However, a precise difference between the ranks really does not exist. And so an example would be looking at t-shirt sizes. There's an obvious difference between a large and a medium, a small and an extra small, but there's really no precise difference between that. Some companies may use a different measurement tool for considering a large and a different measurement tool for medium, so there's not a precise difference between those two. We just know that large is different than medium is different than small, and we can throw those numbers into those categories. The third type of measurement we have, interval level of measurements. This can rank the data. There is a precise difference between the unit of measure. However, there isn't a meaningful zero that exists within this measurement. So here's what an example of this would look like. IQ. There's a meaningful difference of 1 point of an IQ score. So if someone had a 109 IQ versus somebody with 110 IQ, 110 is considered better than 109. But there's no meaningful zero in this because an IQ test would not measure somebody that has no intelligence at all. No matter the person, there is some type of intelligence in that person. So you could not give it a value of 0. So there's no meaningful zero in this. This is an interval level of measurement. Another example of a level of measurement is the temperature of a jumping frog. There is a meaningful difference in just 1 degree of Fahrenheit. So 98.6 degrees to 99.6 degrees. That is a difference. There is a small interval between those two. But again, there's no 0 degrees Fahrenheit. That does not imply that a frog has no temperature. Okay, so there's no meaningful zero in this example. Third type of level of measurement, we have a ratio level of measurement, which possesses all the characteristics of an interval level of measurement. There, this time, exists a true zero. So in addition to a true ratio exists in the variables, the measurements on two different members of that population. So let's see how this works with an example. So you get on Instagram and you look at the number of followers a person has. This person's got 200 Instagram followers as opposed to a second person's 100 followers. They not only have an interval of difference, there's a 100 follower gap between these two people, but we can also state there's a relationship between them. There's a ratio, there's a 2-to-1 ratio in followers. For every 1 follower, the person with 100 followers the other person has 2. And stated another way, this first person has twice as many followers as the second person, but there's also a meaningful zero in there since it is very possible that a person could have 0 followers on Instagram.